Hello everyone and welcome back to our programming series. In this video, we are diving into day 2 operators and control structures, an essential topic for anyone learning to code. Whether you are a beginner or brushing up on your basics, mastering operators and control flow is key to writing effective and logical programs. We will start with the different types of operators like arithmetic, logical, and bitwise, and then move on to decision making structures like if else, and switch. After that, we will explore loops such as for, while, and do while, followed by branching statements like break, continue, and go to. Each slide will be explained clearly with examples and use cases to make your learning easy and practical. So grab a notebook, follow along, and let's strengthen your programming foundation together. And come to the slide 1. This is the overview of operators and control structures, and come to the slide 2. This is the arithmetic operators. The arithmetic operators. First of all, arithmetic operators are used to perform basic mathematical operations in programming. These include addition, subtraction, multiplication, division, and the model operator. The symbols are quite intuitive: plus addition, subtraction, for which gives the remainder after. Hello everyone and welcome back to our programming series. In this video, we are diving into day 2 operators and control structures. It is an essential topic for anyone learning to code, whether you are a beginner or brushing up on your basics. Mastering operators and control flow is key to writing effective and logical programs. We will start with different types of operators like arithmetic, logical, and bitwise, and then move on to the decision making structures like if else, and switch. After that, we will explore loops such as for, while, and do while, followed by branching statements like break, continue, and go to. Each slide will be explained clearly with examples and use cases to make your learning easy and practical. So grab a notebook, follow along, and let's strengthen your programming foundation together. And then come to the slide 1. Slide 1, day 2 operators, control structures. Welcome to day 2 of our programming series. In this session, we will explore some fundamental building blocks of any programming language, operators, and control structures. These topics are crucial because they allow us to perform calculations, make decisions, and control the flow of a program. We will start by understanding different types of operators like arithmetic and logical operators, then dive into conditional statements like if else, and nested if. After that, we will look into loop structures including for, while, and do while loops, which help us repeat actions efficiently. Finally, we examine branching statements like break, continue, and go to that let us manage the program's execution flow. So let's begin. Then come to the slide 2. Slide 2, arithmetic operators. Arithmetic operators. Generally, it is used to perform basic mathematical operations in programming. Then, these include addition, subtraction, multiplication, division, and the modulus operators. Then, the symbols are quite intuitive. Example of addition, subtraction, multiplication, and modulus, which gives the remainder after division. For example, if we write the addition operation 5 plus 3, it results in 8. But if we write 5 modulus 3, the result is 2, since 2 is the remainder. These operators are often used in calculations, loops, and condition checks. Understanding how they work is essential to writing efficient code. Then it is the slide 2, and go to the slide 3, relational operators. Then relational operators are used when we want to compare two values. These operators return either true or false based on the comparison. Common relational operators include for equality, for inequality, for greater than, for less than, greater than, or equal to, so on. For example, if we write 5 greater than 3, the result is true. But if we write 5 equality 4, it will be false. These comparisons are extremely useful in conditional statements like if or while, where we need to decide the flow of the program based on the specific conditions. And come to the slide 4, logical operators. And these operators commonly used in logical operators are help us combine multiple conditions in a program. For example, the three main logical operators are there is the and or not, and then these the and operator stands for these symbols, and it returns only true if both conditions are true. And the second operator stands for logical or and returns true if at least one condition is true. And the third operator is used for logical not, which inverts the result of a condition. These operators are often used in complex conditions. Checks within if statement are loops. For example, if we want to check if a number is greater than 10 and less than 20, you would use the AND operator. So these common calculations, we use the logical operators. And go to the slide 5, assignment operators. These assignment operators are used to assign values to a variable. The most basic is equal to, which simply sets a variable to a value. But there is a compound assignment operators that combine assignment with an operation. For example, plus equal to adds a value to an operation. So these variables and assigns the result back. So if a equal to 5 and we write a plus equal to 3, now it becomes 8. The value is 8. Similarly, there are so many operators are there. The symbols are minus equal to, into equal to, divided by equal to, modulus equal to. These are for subtraction, multiplication, division, and modulus. These operators make our code more concise and easier to read. So that's why the assignment operators are used. And come to the slide 6. These are bitwise operators. Generally, bitwise operators work at the bit level, and it means manipulating individual bits of data. These are mostly used in low-level programming, embedded systems, or performs critical applications. The common bitwise operators include for and, for or, for XOR, for not, for left shift, right shift. For example, 5 and 3 performs a bitwise AND on the binary representation of 5 and 3. Bitwise operations are fast and powerful but require a good understanding of binary number systems. And come to the slide 7, increment or decrement operators. These operators are generally used in increase or decrease the value of variable by 1. These are represented by these symbols, plus for increment and minus for decrement. They can be used in prefix or postfix forms. For example, the plus a or a plus. The difference lies in when the value is updated in In plus a, the value is increased before it is used in an expression, while in a plus it is increased after use. These operators are extremely useful in loop and counters, where values need to be updated repeatedly. And come to the slide 8, conditional statements. The conditional statements, the if statement is the most basic form of decision making in programming. It allows us to execute a block of code only when a certain condition is true. The syntax is simple. If condition evaluates to true, the code block is executed. Otherwise, it is skipped. This structure is fundamental to controlling the flow of logic in your programs. And then go to the slide 9, if-else statement. The if-else statement lets you handle two scenarios, one when the condition is true and another when is false. The syntax is as simple as very simple, and it will be soon we will the syntax will be shown to the screen also. And then go to the slide 10, nested if statement. A nested if statement it means placing one if statement inside another. This is useful when you need to check multiple conditions in a hierarchical manner. For example, you are grading a student, you might first check if their marks are above 50 and then check if they are above 90 for a distinction. Nested conditions help you build more detailed logic and refine the decisions your program makes. And come to the slide 11, switch statement. The switch statement provides a clean way to handle multiple possible values for a variable. It is like a series of if-else statements but more organized. This syntax also will be the easy. After these slides we can show the syntax also, and then each case checks for a specific value and default acts like an else. Don't forget the break statements to prevent fall through for one case to the next. This structure is especially useful to menu driven programs or when working with enumerated types. And come to the slide 12, loops in C. Loops allow you to repeat a block of code multiple times. C provides three main types of loops: for loop, while loop, and do while loop. Each has its own use cases. The for loop is ideal when the number of iterations is known. The while loop is used when the condition is checked before each iteration, and the do while loop ensures the code runs at least once before checking the conditions. And these loops help reduce redundancy and make your code cleaner and more efficient. And come to this slide 13, for loop. The for loop is structured as initialization conditions, increment conditions. There are so many conditions are there. It is perfect when you know exactly how many times you want the loop to run. For example, printing the numbers of 1 to 10 can be done with the for loop. The loop starts by initializing a variable, checks the condition before each iteration, and updates the variable after each loop cycle. It is concise and widely used. And come to the slide 14, while and do while loops. The while loop checks the condition first, then executes the code block. If the condition is false from the start, the loop body may never run. In contrast, the do while loop executes the code block once before checking the condition. This guarantees that the loop body runs at least once. Use while when the loop may not need to run, and do while when at least one execution is required. Both are useful depending on the situation. And come to the slide 15, branching statements. Branching statements let you control the flow of your program beyond the standard top to bottom execution. The break statement is used to exit loops or switch blocks early. The continue statement skips the rest of the loop body of the current iteration and moves to the next one. The go-to statement transfer control to a labeled part of the code, but it's generally discouraged in modern programming due to readability concerns. The statements can be your code more dynamic and responsive when used carefully. And these 15 slides are completed, and go to the examples of these all statements and operators, loops and statements. And then this is the program of arithmetic operators. In the explanation of code is first step is include studio.h. The includes the stand input output library to use printf. And then go to step 2, int main. This is the entry point of the C program. And third step is the int a equal to 10, b equal to 5. It is the declare of two integers a and b and initialize the values. And then fourth step is printf, the operators, addition operator and then subtraction operator, then perform the operators. And this is the program of the arithmetic operators and the value a equal to 10, b equal to 5, and then run the program and then go to the output of this program. And then output of this program is addition is 15, subtraction 5, multiplication 50, division 2, modulus 0. And then process complete, then go to the press enter and go to the program, and then go to the next program, and then program is and clear the, and then we go to the program to relational and logical operators, then hash include and this is the relational operator and logical operator is small program, and then we run the program and the output of the program will be shown. The output of the program will be shown, and go to the press enter, back onto the program, and these are the small and clearly explained programs. And then we go to the next program, and then we print the natural numbers using while loop. Some of the first n natural numbers we will show the program and clearly explain the code. And this is the program is sum of first n natural numbers using while loop. This is the program, and then using while loop and then output of the program will be sum equal to 15, and this is the program. And then we go to the some program. The program is check even or odd using if else statement, and then we already saved the program, and I open the program. This is the program checking even or odd using if else statement. The program is there, and then the number is we used 7, and checks its remainder, and then true or false, and then the number is even or odd, we check them and run the program. Yes, the number is odd, and then we go to the back, and next we initialize the another number. The number is 20, and run the program. Yes, the number is even, and then we initialize another number 27 and run the program, and then the number is odd. Next we will go to the another program, and then go to the some simple for loop program, then open loop.c, and the program is simple for loop print 1 to 5, and then we run the program. Yes, the output will be show it 1 2 3 4 5, and press the enter, back to the program, and give to the another number to the program, that is Yes, the output will be show 1 to 10.